All right, we're going to do some more limits. We're going to do them algebraically, and we're going to do them graphically. So let's get started.
Once you get the hang of it, maybe you want to pause the video and try it out before you actually see me do the answer. So let's learn how to read this first. So for number 1, it says the limit as x approaches 3 of 5x plus 2. And all you have to do is take that 3 and plug it in. That's the algebra part. So basically, it's just going to be 5 times 3 plus 2. And when you plug that in, if you do your order of operations correctly, that's going to be 15 plus 2. So that answer is going to be 17. So if you have the hang of it, if you think you have the hang of it, for number 2, maybe you'll want to pause it and see if you can't work ahead. So for number 2, we're going to try to limit as x approaches 5 of x squared minus x. A little bit more difficult. Let's see if you can't do it. So here's what I'm going to do. I'm going to take this and I'm going to plug the 5 into the x. So that's going to be something squared minus something. So it's going to be 5 squared minus 5. So it's going to be 25 minus 5, and that's going to equal 20. Now I'm going to start spinning off into more difficult stuff. Let's see if you can't hang. This one is a little strange. The limit as x approaches -1 of just 7. There's nowhere to plug it in. So this one you actually have to know that it's just going to be 7 is the answer. Not -1, it's just 7. Nowhere to plug it in. Number 4. Limit as x approaches 2 of x squared minus 4 over x minus 2. This one is a little tricky. Notice, if we plug 2 in, if we put 2 in the bottom, we get 2 minus 2. So that's going to equal 0 on the bottom. If I put 2 in the top, 2 squared, that's 4. And 4 minus 4 is 0. So looking at this, that spells oops. That means we can't do it. You have to do something else. No oops. The trick is to factor x squared minus 4. So x times x equals x squared. 2 times 2 equals 4. And it's going to be plus and minus. And that's going to all be over x minus 2. And notice the x minus 2's will simplify. And that just leaves me with x plus 2. So I'm going to redo this limit as x approaches 2 of x plus 2. So if you get 0 over 0, you're going to have to factor or do something else in order to break it down a little bit further. When I plug the 2 in now, that's going to give me 2 plus 2. So that limit is actually going to equal 4.
I want you to have to copy this down, so just look at the picture. And this is a graph. And the name of this graph is f of x. So take a look. It's this strange graph. Now I'm going to be upfront with you.
This is what they do at FAU in methods of calculus, or survey of calculus, to go over limits graphically. PBSC does not do limits on the graph. PBSC does not do limits on the graph. Number 5. So using this graph, I want to find out what the limit of f of x as x approaches -3, and this is really strange. I'm going to put a little positive sign up here where the exponent is. So I want to know what the y value is as I approach -3 from the right. And notice on my graph, I have the left side over here on the left and the right side over here on the right. So I'm going to approach -3 from the right. So I'm coming from the right, and I'm getting closer and closer to -3. As I get closer and closer to -3, what y value am I getting closer and closer to? What's that y value there? That y value is 2. That's it. So let's try another one. Number 6. What's the limit as x approaches -2? But this time, I'm going to put a little negative up there where the exponent is. So that means I'm approaching -2 from the left. I have to put in the statement, that's the graph f of x. So, as I get closer and closer to -2 coming from the left, what y value am I getting closer and closer to? Notice that y value is going to be 1, 2, 3. The y value there is 3. 1, 2, 3. As I get closer and closer to the x value -2 from the left, I get closer and closer to the y value 3. Number 7. Limit as x approaches 1. I'm sorry, -1 from the right of f of x. So as I get closer and closer to -1 from the right, so I'm coming from the right, what y value do I get closer and closer to? The y value there is 4. Now we're going to do some strange ones. Number 8. The limit as x approaches 0 from the left. And the equation that we're looking at is f of x. So as I get closer and closer to x equals 0, notice from the left, what y value do I get closer and closer to? And notice this time, it's going to be up here at 3. Now for number 9, it's going to seem like the same problem. The limit of f of x as I approach 0, but this time from the right. Because there's a positive there, I'm coming from the right side. And notice, as I get closer and closer to 0, from the right, what y value do I get closer and closer to? Notice it doesn't have to equal the y value. I keep using the terminology, closer and closer. What y value am I getting close to? And that answer is 1. I get closer and closer to the y value 1. And now number 10. The limit of f of x as x approaches 0. But notice I didn't put anything up there. I didn't put anything up there. Because there's nothing in the exponent, you're technically supposed to look at it from the right and the left. But they don't put plus minus. They just leave it blank. So I'm going to see if it approaches it to the same spot from the right and the left. Now we know the answer to this because from the right, it was 1. From the left, it was 3. And because they don't equal one another, as I get closer and closer to 0 from the left and right, notice they're disjoint, they're not together. And then you're supposed to jump up and down and say, the limit does not exist.
The limit does not exist. The limit does not exist.
So now we're going to set up 3 problems, 11, 12, and 13. Notice they all look the same. Limit as x approaches 2 of f of x. The limit as x approaches 2 of f of x. The limit as x approaches 2 of f of x. So in order to make them different, I'm going to say as x approaches 2 from the left, as x approaches 2 from the right, and then I leave that blank. And that means I'm coming from the left and the right. So let's see what the limit as x approaches 2 from the left is. So here's 2, I'm coming from the left. What y value do I get closer and closer to? What's that y value that I get closer and closer to? It's going to be 1. What's the limit as x approaches 2 from the right? As x approaches 2 from the right. So here's the right side. I'm getting closer and closer to the x value 2. What y value do I get closer and closer to as I get closer and closer to the x value 2? The y value that I get closer and closer to as I get closer to 2 is y equals 2. Now, as x approaches 2 from both sides, notice these two are different. So the answer to that is the limit does not exist. DNE.
Anything. The limit does not exist. The limit does not exist.
So here we go, 3 more. Limit as x approaches 3 of f of x. Limit as x approaches 3 of f of x. Limit as x approaches 3 of f of x. So I can't ask you the same question 3 times. So I'm going to make them different by putting from the left, from the right, and then from both sides. So if I have a little negative where the exponent is, I'm approaching 3, y value, x value 3 from the left. And notice the y value is 3. As I get closer and closer to this x value 3 going from the left, the y value I get closer and closer to is 1, 2, 3. As I get closer and closer to this x value 3 from the right, I get closer and closer to 3. And now, because they're the same, the limit as x approaches 3 from both sides, if the left-hand limit is equal to the right-hand limit, then the answer is not going to be D and E. It's going to be 3.
We want to invite you to have lunch with us every day for the rest of the week. Oh, it's okay. Coolness. So we'll see you tomorrow. On Wednesdays, we wear pink.
Okay, trig limits. If you are going in the survey of calc, or methods of calc, or business calc, you do not need to look at this. If you're lazy and you're going into calc 1, calc 2, or calc 3, you don't have to look at this. This is just extra. So we're going to do some trig limits. I want to know what the limit as x approaches pi over 4 of sine x is. So in order to do that, these are basically algebraic limits. You want to plug in pi over 4. So I need to find out what sine of pi over 4 equals. And then here it comes, the big trig table. So I need to find out what sine of pi over 4 is. So I'm going to scroll over to pi over 4. Sine of pi over 4 is root 2 over 2. And that's how you do it. You could also use the unit circle if it's just sine or cosine. Tangent. So what I want to do is I want to take this pi over 3 and throw it in for the x. So I need to find out what tangent of pi over 3 is. I'm going to get the trig table. Find the tangent row. And find pi over 3. I believe it said pi over 3. Yeah, pi over 3. So I'm going to scroll over till I get to pi over 3. And that answer is root 3. Cotangent. So I take the pi, I throw it in. So I'm looking for cotangent of pi. So let's find that. I know it's on the bottom row. So there's cotangent. And find out where pi is there. And notice, it's undefined. So here it comes. That means the limit does not exist.
The limit does not exist. The limit does not exist.